Now let's look at another method for solving a quadratic equation, and that is using the square root property. So we see we have two basic steps. First, we isolate our squared term, then we take the square root of both sides. But now there's a couple notes that I want to draw your attention to before we actually solve the equation. We need to know when it's appropriate to use this method, and there's also a very important step that we have to remember. So first, let's talk about when you can use this method. So the square root method may be used anytime your bx term is 0. So when we use that square root property, our bx term has to be 0. So what I mean by that is if you refer to standard form, ax squared plus bx plus c equals 0, if you notice that the bx term is 0 or is non-existent, then you know that you're able to use the square root property. So if you notice that you have your bx term equal to 0, then your equation will look like this: ax squared plus c equals 0. Notice the absence of the bx term in the middle of the trinomial. So now it's just ax squared plus a constant c equals 0. So when that happens, you move the constant c to the right side. But before I continue with the definition, let me give you one other way to identify when it's appropriate to use the square root property. I also say if you only see the x variable one time, so like we only see x in the equation once, and it's also being squared, then you know you're ready for the square root property. So one occurrence of x, you don't see x squared, and then another x term, you just see x once and it's being squared. When you have that set up, you move the constant c to the right side of the equal sign, which means you're basically isolating the squared term. Then you'll divide both sides by a, and then your last step is to take the square root of both sides of the equation, and then that is where you have to make sure you remember about the positive and negative root. Because remember, you should still get two solutions because the degree of your equation is still 2. The x is being squared. When the x is a power of 2, that means you're going to get two solutions. That's where the positive and negative root come in. Okay, so let's look at our equation. 2x squared minus 18 equals 0. So what I notice is that my bx term in the middle is 0. This is the same as 2x squared plus 0x minus 18 equals 0. So I have 2x squared minus 18 equals 0. So I want to start by isolating 2x squared. So I do that by adding 18 to both sides. That was where it says move the constant c to the right side. That will give me 2x squared equals 18. Now I want to divide by my coefficient of 2, so I get x squared equals 9. Now, we can solve this equation by inspection. That means you could probably just look at this and tell me what your solution is. So I'm looking for some unknown number so that when I square it, I get an answer of 9. Well, right away, you're probably thinking 3, because 3 squared equals 9. But remember, we said we should have two solutions. So is there another number that I can square and get an answer of 9? Well, yes, there is. It's also negative 3. So negative 3 squared is also equal to 9. So the plus 3 or the negative 3 are my solutions. So if I go back to x squared equals 9, this is where the square root property comes into action. That means x equals plus or minus, or the positive or negative square root of 9. So x equals plus or minus 3. Or I can write it as a solution set, negative 3 and 3. So now I have two solutions for my x variable.